Hello and welcome to another video session of Geek Wheel. We're going to talk about graphing linear functions, and we're going to be using that book called Big Ideas Mathematics Algebra 1 Common Core. Okay, so we're going to define functions as in Big Ideas Mathematics Algebra 1 Common Core. So let's look into the first exercise of chapter 3, graphing linear functions. Okay, 3.1 is about functions. Let's load that. Have a look. Functions, essential question, etc., etc. Okay, the first thing that we see is the definition of function. Very simple definition he has used over here is a relation pairs inputs with outputs. Simple and easy way to define a function. Just one relation that pairs inputs with outputs. For example, if I have, let's get rid of that. If I have, say, y equals to, if I have, say, y equals to x plus 1. Alright, so this is my input. This is my input and this is where the outputs are going to be. So this is the output. So this is the relation x plus 1 equals to y, or y equals to x plus 1 is the relation that pairs the inputs with the output. For 0 it's going to be 1, for 1 it's going to be 2. So this is what's linking them, right? And that's what we call the function as mentioned over here, as defined over here. Okay, exploration 1, describing a function. By an equation we can define it, by an input-output table. Very good. We can also call it function table using words. Yes, the output is like here we can say the output is one more than the input, right? What else? Using words. By a graph, obviously one of the very significant notation. As a set of ordered pairs. Yes, input comma output ordered pair, or what you locate as a point on the graph. The xy coordinates of that point on the graph are what you call the ordered pairs. Okay, exploration 2, identifying function, work with the partner, etc., etc. And we've been given these questions and we have to identify if there are functions or not. So let's look into that and let's find out the reasoning behind this thing as well. Now the simple way I prefer solving these type of questions is that you see, if every output has unique input, functions or relations, they stay function as long as the input stays unique. For example, if you look into the first one, A, all the inputs are mapping to one output, 8, right? If you write them down in the form of ordered pairs, you will see that for 0 it's 8, for 1 it's 8, for 2 it's 8, for 3 it's 8, for 4 it's 8. These are all the ordered pairs I got. For each of this output, in other words, if I say for all of these 8s or for different ordered pairs I got, the input is unique, right? The input is not repeated. Right, so this will be a function. For this one, as you can see, the input is repeated. The moment that happens, it's not a function. Alright, so we can say, in other words, that one input, if that maps to two outputs, output 1 and output 2, then in this case we will get an ordered pair like input comma output 1 and input comma output 2. See, the input will be repeated. So we can say, in other words, one input cannot map to two outputs if the relation is to be a function. So, or in other words, we can say this cannot be called a function. Another way we can describe this thing is, if I have something like input 1 and input 2, two inputs mapping to one output. Okay, So in this case, I'll get ordered pair like input 1 output and input 2 output, right? So two inputs can map to one output because if you look, the input is unique in case of each ordered pair. So if you look at this one, see, this output has this input, this output has this input. Now there are two outputs which share the same input. So if we write it down in the form of ordered pair, we get 310 and 311. Input is repeated, right? So that will not be a function. D now. If you look at this one, we're going to be doing another method which will tell us whether this thing is a function or not. But if you look at this one, you can locate the points and write them down in the form of ordered pairs. Like if you look at this one, the very first one, let's look at this one. This is 0, 8. This one is 1, 6. This one is 2, 4. Now here we have 3, 2 and 4, 2. This one is 5 is mapping to 4, and again 5 is mapping to 4.5. Right? For this one I have 7 is mapping to 4.5. 7, 4.5. Another ordered pair I got for this one is 7, 8. In this case you can also write it down in the form of ordered pairs. 5 is mapping to 4 as well as 5 is mapping to 4.5. Right? So for these cases, for these ordered pairs, we got the input in the repeated form, right? The input is no longer unique anymore, so this cannot be called a function. Now let's look into that one. So if we look at this one, it has a few more questions which you can practice using this concept that one input, if it maps to two outputs, then it will no longer be unique input. But two inputs, if they map to one output, then each ordered pair will have unique inputs, which we can call a function. Right? Now let's look into this one. The first one, if we look at this one, -2, -1, 0, 1, 2. Each input is unique, so we will say it is a function. Let's see. So the relation is a function. Look at B now. 4, 8, 6, 4. Oh, what happened? 4 is repeated. It will not be a function. Let's look at this one. So the relation is not a function. C. Let's check if every input is unique. Oh, we got 5 output for 0 input and 6 output for 0 input as well. This thing, two outputs share the same input, right? The input is not unique anymore, so not a function. D now. Let's look at D. It says 1 is mapping to 4, 3 is mapping to 15, so as 11 is mapping to 15. Two different inputs mapping to one output. We're gonna get ordered pair like 315 and 1115. Each ordered pair will have unique input, so this one will be a function. Relation is a function. Now let's look at the next one. So you can practice these questions in the monitoring progress. Core concept, very important thing, vertical line test. If you have been given the graph of the function, you don't have to locate points, or you don't have to write them down in the form of the ordered pairs to figure out if it is a function, or you don't even have to draw the mapping to figure out if that represents a function or not. You can just go for the vertical line test. The vertical line test is as simple as its name. Just draw a vertical line on the graph. If it cuts the graph exactly at one point exclusively, then it is a function. If it cuts the graph more than 1 point, not a function. Simple and easy. Alright, we can look at this one. Okay, determine whether each graph represents a function and explain. Now let's take them to the board. Okay, let's get rid of this one. We have been given these two graphs and we have to find out whether they represent a function or not. Vertical line test, cutting at 2 points, 2 points, right? Cutting at one point exclusively, right? So this one will be a function and this will not be a function. Look at the answer. You can draw a vertical line through 2, 2 and 2, 5. So the graph does not represent a function. No vertical line can be drawn more than one point on the graph, so the graph represents function. Simple. If it cuts at more than one point, not a function. If it cuts at one point exclusively, is a function.